Good evening, Professor. This is my fourth assignment of MMIC IPT, and today's topic is about optimized process for manufacturing IPD. In this chapter, what I have studied, I will represent through my presentation, and in this topic, the subtopic was high precision NICR TFR. In this, to create an integrated resistor and material, provide and adjust sheet resistant good patterning properties as well as low temperature coefficient is necessary. This sheet 80 resistance can be varied from 10 ohms square meter to 100 current square. By using different deposition techniques, it can also be layered of metals. In this table is about detailed information of dimension and material property. What is the E-beam and machine AIE 20s, 120s and 30s and 15s and 15s plus. In this first metallization optimization, the process are mainly related to AR plasma treatment during the RIE of the unwanted TiAu layer during the O2H2 plasma cleaning process that is used to remove the unmandatory photoresistant. In this sheet Ti and Au sheet metal secreting prior to electroplating is used to improve the metal adherence to the substrate. Plating is the process in which the layer of metal is deposited on the item to be electroplated by using an electric current. In this this slide is about, in order to get a better humidity, a thicker NICR deposition, 25 current square sheet resistant target the slower deposition rate. In this sheet resistance ranging from 24.35 to 26.16 current square was measured on 10 different wafers, which is given in figure second figure, that is 3.2, and is superior to the previous TFR process. The variation in the maximum sheet resistance are within 4.6%. The 3 sigma variation is around 3%. This slide is about the effect of healing on the electrical properties of TFR. A single layer PT layer is a successful material of resistor with low temperature coefficient. AU, CU, NICR, PT multi-layer are substrated like SI, and GAAS has been deposited using newly developed high-rated Magneton separating process. And in SEM photograph this figure with the previous figure 34 with the previous slide clearly indicates the indiffusion resistive measurement from room temperature to 200 degrees Celsius, which carried about using the 4-probe method. In this 4-probe method, avoid the necessity of measuring the cross-sectional area. Also is suitable shaped, and it is also accurate method for the determination of resensitive, and the result of measurement are presented on the iris plot, as you can see in this figure, first figure, for the different substrate. And this slide is about high Q and high yield spiral indicator. In this subtopic, classical spiral indicator, Sonnet software are used for this simulation, EM simulation, and DC and RF measurement. Simple transmission line has been used to determine the metal conductivity and substrate loss tangent. To measure this, derived values were used for simulation of several spiral indicator with the different lines with spacing, metal thickness, and turn numbers. In 3.5 figure shows the simulation and the measurement result of an inductor before and after packaging global top. In 3.8 figure compares the simulated and measured. First figure is about inductions, and B figure is about Q factor of three different induction values ranges from 2.68 to 1.3.35, and the value ranges from 10 to 15. And this second metallization optimization. In this process, in order to compensate this, it is much thicker, 7 meter thick CU and AU top metal needed to be added according to 3D EM simulation analysis, because the thicker plated top metal can provide very low resistance loss, which in turn result to improve Q factor with reduced RC time constant. Otherwise, the compact spiral indicator of size, especially of those with a very small coil with an air bridge metal, often peel off during the light off process because of poorer adherence between the top metal and the second seed metal. The interaction deep of the subter etching is around 100 beneath of a surface of solid in Bombardier Argon. A Q factor is more than 30 and up to 100% yield is thereby fabricated inductor. This is a model development of differential inductor. As you can see, I have mentioned three figures, figure A, B, and C. A is about the layout of an octane differential inductor with three metal layer. In this octal spiral inductor have which provides a high Q factor and lower series resistance than other. Square pattern is more area efficient. And B figure is about equivalent circuit of the inductor. In this modeling process, capacitive coupling between the metal lines that are parasitical associated with the air bridge should be considered. All of the components that are used to account for metal track. In B figure, this figure last figure is imposed model of segment box. In this, the double L bridge overlap dimensions, capacitive parasitic effect through the series capacitive effect, which allow the realization of higher Q factor and induction. In this N2 annealing and O2H2 pre-treatment of SiNX thin film. This it has a two figure. The first figure, it has a PTC measurement result for 4 different situations. And the second figure is about cross-sectional photograph of MIM capacitor measured by FIB. In this, in order to improve the reliability and in the consistency of SiNX film, N2 N2 annealing and O2H2 plasma pre-deposition treatment have been explored. When using this pre-deposition treatment, breakdown failure rate greatly decrease the highlighting of interface between the metal electrode plate and curicle role in reliability of MIM capacitor. Uh, this process enhances the advance of nitride to the metal electrode and reduce the delamination of SiNX thin film in high pressure, high temperature and high humidity environment. PCT measurement result are demonstrated in this figure, in this first figure, and it is more extensively reliability test including a high electrical stress test and thermal cycling is about 150 degrees Celsius has been performed. In this film with the N2 annealing or O2H2 plasma treatment performed better than comparability to the films without any pre-treatment. This SU8 final passivation of IPD. The first figure with is a change in resistance of contact change in storage state. A test performed at 85 degrees Celsius within 85 degree relative humidity. It's in this contact chain structure with the thickness of TiPTU 50-3600 nm was used to evaluate the equality of passivation layer. The contact chain monitor passivate with the 20 meter thick SU8 film of 300 nm thick SiNX thin film were fabricated for test samples, and the as you can see there is a detailed structures and result are shown in this first figure 3.30. You can go through, you can see the changes and everything has been set in this diagram. And the second figure is a image of SUV, and the first is the after cooling the curing process, and second without cooling the curing treatment. Our method of removing the micro cracks involves adding a cooling process of 3 minutes at room temperature after soft baking of PEF and final hard baking process to reduce the thermal stress. And for reducing purpose during the cooling phase, become the polymer can rearrangement occur in the resistance not cross-linked. Difference between SU8 structures with and without the cooling and curing steps can be observed in SEM micrograph. In this figure you can see. Okay, this topic is about optimization of IPD manufacturing process. As you can see, I have described 2 photographs. First of A is about PECVD and second is E-beam evaporator. In this, it's a process start with the first passivation layer composed of SIX deposit of PVCD. In this first figure, there is in this layer is necessary in order to attain even surface over the defect of roughness of substrated surface, and the e-beam evaporated layer is deposit the target 90% Ni and 10% Cr to achieve the optimal performance. Next step, step second, the wafer is masked using the photoresistant in order to define and bottom metal layer structures. And in third steps, 50 upon 450 nm thick TiAu metal layer is then formed by an e-beam evaporator. And in figure B you can see this layer is used as a contact metal of N for the NICR TFR, the bottom metal layer of for the MIM capacitor, and the metal being line and coils for the spiral inductor. The MIM capacitor middle dielectric has been created. A 2000 Assignment4 layer is deposited by PECVD and marks to define the structure. In fifth step, the after deposition, RIE use inductively coupling the plasma IPCT in IPC. In this figure first figure is about ICP RIE, and the second is about cluster sputter. In this continuing the sixth step, uh, the a thick TiU sheet metal layer followed by an air bridge post photo process is deposited by structuring. And then the seventh step is about at the seventh step average photo process, and the eighth step is performed prior to a CU-AU 6.5 upon 0.5 meter top metal definition and mantling process. IPD in this figure, after this, the equipment for IPD manufacture. First figure is about plating machine, second figure is about lift off machine. In the first figure, by which top metal and air bridges are made for the capacitor, and the air bridge interconnection performed at the broken coil path and round metal benefit for the inductor. After electroplating process, air bridge mask is stripped by the lift off machine. In the figure B, RIE and TiAu seed metal is done. In the last and the final step, ninth step, all the components are passivated with 20 SU8 layer in order to protect the component oxidize and moisturization. And thank you for this assignment. Thank you for the day.